Hey, what's going on, guys? So this is going to be a pure beginner tutorial in machine learning, and we're actually going to be using JavaScript. Now, I know Python is the king of machine learning and AI, but there are some pretty cool tools in JavaScript to deal with neural networks and machine learning and AI. So we're going to use something called Brain.js, okay? And I am by no means an expert at machine learning. It's actually something I'm studying now. So this isn't going to be like a cookie cutter, professional tutorial by a machine learning expert. That's definitely not what this is. I'm just sharing with you guys things that I'm learning along the way. Okay, so keep that in mind. In addition to just using Brain.js and showing you the syntax, I want to talk a little bit about neural networks because a lot of people have no idea what a neural network is, and you probably hear that term all the time. So, and we're not going to get deep into it, but just so you kind of know the gist of it, basically, you can almost think of a neural network like a human brain. So it has thousands of interconnected artificial neurons which are stacked into layers. Okay, so these are all layers. So we have the input, we have all the hidden layers, and then the output. So in most cases, neural networks are what are called feed forward, which means the data moves through them in a single direction. So single direction, here to here, all going that same direction. And this allows us, what this allows us to do is what's called deep learning, where we can feed it vast amounts of labeled data, and it can be trained to interpret that data, and in some cases better than a human brain. Okay, it can also be trained to do predictions, to make predictions, which I'll give you a very, very simple example of using Brain.js. So a neural network can perform some task or give some output or make some prediction by analyzing what are called training sets or training examples, training data. There's a lot of words for it. And it's very, very important to know that your data is everything. So if you have a very small data set, the probability of your neural network actually giving you a good result is very low. So the more data you have, the better. And of course, the more accurate your data is, the better it's going to work. Okay, so data is definitely everything. And usually these sets are hand labeled. So I guess a simple example would be like labeled images. Let's say you had a bunch of images of dogs, cats, and birds, and you would use this training data to teach the computer what an image of a dog, an image of a cat, or an image of a bird looks like, and it would find visual patterns based on that data and correlate them with the labels, and it'll eventually just be able to identify if an image is a cat, a dog, or a bird all on its own. So you're essentially training the computer to do something or to interpret something or predict something. Obviously, this is a very simple example, but it gives you some context into what neural networks are used for. Okay, so they're used to basically train a computer to learn something, which machine learning. And this goes hand in hand with artificial intelligence. So let's see. What I want to do is just kind of show you how to set up Brain.js. We're going to use Npm. There's also a CDN if you want to use it strictly on the client side. Now down here we have some examples. We're not going to be really dealing with like configurations and stuff. I want to just teach you very basic stuff, how to create a neural network, how to add training data, and how to run something against that network. And what will happen is it'll give you a probability between 0 and 1, so in this case 98%, that the output will be a 1. So here they're just using with an array of 0, 0, 0, 1, 1, 0, 1, 1, and they're setting an output of 0 or 1 for each one of these, and then they're running against it what the probability of this to be a 1. Now this is actually in the data set, so obviously it's going to be a very high probability. So that's 98.987. But what we're going to do is, or one of the things we're going to do is take from this article here on neural networks, this example which we're going to add this as training data. I can't highlight this, but basically all of this, example 1 through example 5, is training data, putting in our input and output, and we want to be able to run this against our neural network and get the correct answer, which would be 1. Now the reason it would be 1 is because what's happening is the output should be the first number of all of these. Okay, so our neural network should be able to take this training data and learn and be able to tell us that the output of this should be a high probability that it's a 1. Okay, so we should get like 0.9 something. So that's the idea that I want to do, and we'll do a couple other things as well, but this is the first thing we'll do. So let's jump in to VS Code. And if any of you guys are like machine learning experts and I make a mistake or whatever, feel free to leave a comment, because I am by no means an expert. I know a lot of different areas of programming and development, but this is one that obviously this is a new kind of programming. So this is new to me. But if I do make a mistake, feel free to correct me. Just don't be a dick. So first thing we'll do is npm init to just create our package.json. So I added the -y so I didn't have to answer any questions. And then we're going to install, so npm install Brain.js. Okay, make sure you put the dot, and make sure you don't do just Brain. I believe that's an older package. So let's see, we want to create a file, and I'm just going to call this index.js. You can call it anything though. Let's clear that up. And we're going to bring in Brain. So we want to require Brain.js, and let's create a network. So we'll set that to a new Brain.neural network. Okay. And now we need to add some training data. So to do that, we take our network variable and we say .train. And we're going to pass in an array of objects that have an input and an output. Okay, and if you've used any Python libraries or anything like that, you're going to see the similarities, or even if you've used other JavaScript libraries. I know there's like TensorFlow, there's, I don't know, I can't remember the other names. So we want an input and we want an output. Okay. And we want like 5 of these, right? Let's see, 1, 2, 3. Yeah, so we'll do that. And we're going to follow the this article, this table here, at this training data, so the input and output, and then we're going to run this against the network. All right, so let's see, let's say 0, 0, 0. And then this one was 0, 0, 1. We got 0, 1, 1. Then this one should start with a 1, and then 0, 1. And then this one will be all 1s. Okay. Now for the outputs, remember what we're doing here is using the first digit as the output. So these last 2 will be 1. All right, so let's save that. So that's our training data. It's a very small data set. Usually you'll have a ton of data in your sets, but this is something that's very simple that it should be able to figure out. So now we'll create a variable. I'll just call it output. You call it result, whatever you want. And let's say network.run. Okay, so what do we want to run against our neural network? So we want to run 1, 0, 0, right? Is that what the article did? Yep, 1, 0, 0. So this is the unknown, right? This isn't actually, like, we didn't add that as actual training data. Whoops, what the hell am I doing? So that'll put it in a variable, but we want to be able to see it obviously. So let's say console log, and I'm just going to put some backticks. I'm just going to say prob for probability, and then we'll put our variable of output, and it'll show us what we get. So let's save this and let's run it by saying node index. That's the name of the file. and we get 0.908, and then, just a whole bunch of numbers. So basically a 90% chance that this will be a 1. Okay, so that's good. Now, if we were to put something in here that starts with, actually, let's just do like 0, 0, 0, that should give us a very low probability that this will be a 1, that the output will be 1. So let's go run that, and we get 0.06. Okay, if we do 0, 1, 1, even though that is actually in the data set, it'll probably be higher than that. Oh no, so we still get 0.06. Okay, if we put, let's see, all 1s, we should get very high. So 0.91. Yeah, so let's do, what don't we have in here? 1, we don't have 1, 1, 0, but that should also give us a pretty high rate, high percentage. So, yep, 90%. Good. So it's working how it should. And this is, I know this is a pretty useless example. I mean, it's not really, it's not real world data or anything like that, but I just want to kind of show you how it works. So let's kind of do the same thing, sort of, but with more context to it. That makes more sense. So I'm going to just comment that out and paste this in, and we're going to have 2 values for our input, and we're going to think of these as teams, like let's say baseball teams. Okay, so we have team 1 through 4, and we're going to say, for instance, team 1 plays team 2, and the winner, if we keep the output as 0, that means team 1 won. If we put 1, that means team 2 won. Okay, so we're going to put this as 1 because I want team 2 to win. So we're going to say team 2 wins. And I know it's really, what I find difficult is putting everything into numbers. And it's not necessarily math. I mean, I did. It's funny, I just did a video on math and programming and said how it's not required, which is definitely true. It's not required in many, many areas. Machine learning, however, is one of the areas that math is going to seriously benefit you. Even though we're not really doing any math right now, but there is math included when you get into tougher stuff. All right, so, I did say that it was required in some areas. So let's say 1, 3, and again, I want team 1 to lose, so let's say team 3 wins. So we want to put a 1 here, because remember, if we put a 1, that means the second number here, 1. Okay, so this next one, let's say that team 2 plays team 3, and we'll keep that as 0, so we'll say team 2 wins. And then this one here, let's say that team 2 plays team 4, and we'll keep a 1 for that, saying that team 4 won. Okay, so I just want that for now. Let's get rid of that. Let's get rid of this last comma. And then what I want to run against this is if team 1 plays team 4. Okay, so what this should do is give us a probability of if team 1, if this should be a 1 or not. And remember, a 1 means the second team wins. So it's going to give us the probability of team 4 winning, which should be pretty good because team 1 has lost 2 games, right? Team 4 has won 1. So let's run this and see what we get. We'll clear this up, run it, and we get a 99% chance that it's going to be a 1, which means that team 4 is going to win. Okay, now I just want to show you that changing the data will seriously change the results. So I'm going to, let's see, I'm not going to type that in. Let's actually just put a comma here and we'll copy this down. Let's do 3 more games. So let's see, this game here, let's take team 1 and have them play team 2, and we'll have this as 0 because we actually want team 1 to win. I want them to win 2 games, so 1 and 3. and let's say 0, meaning team 1 wins. And then let's actually have team 4 lose a game. So we'll have team 3 play team 4, and we'll change this to a 0, meaning that team 3 won. So now we've seriously changed the data because team 1 has now won 2 games and team 4 has lost a game. So this probability should change and should lean more in the direction of team 1 winning, meaning that it's going to be closer to 0. So let's go ahead and save this and let's run it. And we get a 50% chance. And if we run it again, we'll get something a little different, not much. 49, 46, 48, 40. And you can change the options like the iterations and stuff like that. But I don't want to get too deep into this because I don't want to start to talk about stuff I don't know what I'm talking about. So that's another example, and hopefully that makes a little more sense that now that has a little bit of context to it rather than just the numbers. But now what I want to look at is something called long short-term memory, because I want to deal with strings. Because if you want to deal with strings with just a regular neural network, you basically have to encode each string character into a value between 0 and 1, and it gets really complicated. In fact, there's a tutorial right here, and I'll put this in the description, where he uses Brain.js to basically figure out if a certain tweet is by Donald Trump or by Kim Kardashian. He doesn't use their actual tweets. He uses a hard-coded data set, which is right here. So he uses this as his training data. So the input he has just basically a tweet, and then the output as Kardashian 1, and then, Kardashian, Trump, so stuff like that. And basically what he has to do, since he's using strings, is run everything through an encode function that's going to turn each character into a value between 0 and 1. So it can get pretty complicated to do something like this just using neural network, just using this brain.neural network. So what we have available to us is long short-term memory, which is, let's see, where the hell is it? Where is that example? Right here. Yeah. So here you can see when using RNN, LSTM, and GRU, it can be an array of values for your input or training pattern. It can also be a string, and there's an example here where they're using a string. Okay, and so all you have to do is, instead of doing brain.neural network, you do brain.recurrent.lstm. Okay, and RNN is actually recurrent neural network. It gets really complicated, guys. I'm trying to just keep this as simple as possible. But my goal for this next little, project or whatever, is to take a data set and train the neural network to recognize if a piece of text is related to hardware or software. Okay, so it could be, a log for a team, or it could be a phone text. It doesn't really matter, just a piece of text, like a sentence, and we want to figure out if it's hardware or software. Okay, so I'm actually going to bring this in as a JSON file. I'm going to show you how to do that as well. So let's create a new file here, and I'm going to call it data.json. And this is going to be our training data. Okay, so I'm going to just paste this in, and I'll have this in the GitHub. Okay, and I got this idea from, I think it was a Stack Overflow post. They were trying to figure this out, so I figured that I'd use this. But we just have an array, JSON array, and then each object has a piece of text. This is my unit test failed, and we have a category of software. Okay, here we have tried the program, but it was buggy. We have software. I need a new power supply, hardware. The drive has a 2 terabyte capacity, hardware. So just certain phrases. You could just use keywords, like here we just put drive, hardware. And you could add more. The more data you have, like I said, the better it's going to work. But we should be able to put a sentence like, I don't know, I added memory or something like that, and that's not an actual text in here, but it should still be able to know that that's related to hardware. So that's really the goal of what I'm trying to do. So I'm going to save this file, and I'm going to use I'm not going to use index.js. I'm going to keep that as is and create a new file, and we'll just call this index2.js. All right, and if you do add to the GitHub repository, just call it index and then whatever the next number is, so if there's an index 3, if that's the last one, just do index 4, something like that. I just want people to have more examples because there's really not a lot online. There's not a lot of examples online. So now we're going to, this is actually going to be pretty easy. It's not going to be that much code. So we're going to bring in Brain.js. So let's say brain equals require brain.js. We also want to bring in our JSON file. So let's call this data, and let's say we want to require, and we want ./data.json. Okay, and let's say const network. So this is actually going to be it's going to be brain.recurrent. It's going to be a recurrent neural network, and we're using long short-term memory so that we can deal with strings in the way we are. So let's say brain.recurrent.lstm, like that. All right. So now what we want to do is add the input. If we look at our data, we want the text to be the input and the category to be the output. So, and I mean, I could have just hard-coded the input and output, but I want to show you how we can actually use a JSON file and basically map through it and create our input and output. So we're going to create a variable called training data, and we're going to set it to data, which is the JSON file, and we want to map through. Map is just a JavaScript method, and it just loops through an array, and it can create a new array from that. Okay, so we're going to just call each one item, and we're going to use an arrow function here, and let's go like that. So we're basically just creating a new array object for each one, and then it will have input, which will be the item.text, and then let's have the output as the item.category. Okay, so the text and category is coming from here and here. So these could be called anything. Okay, so that's our training data. Now, just like we did in the other file, we're going to say network.train, and we're going to pass in our training data. Oops, training data. Okay. Now, this takes longer when you're dealing with long short-term memory. It takes longer, and I think the iterations by default is like 20,000 or something like that. And the more iterations, the more accurate, but the longer it takes. So I'm actually going to add in a config option of iterations, and I'm going to set that to 2,000, okay, instead of 20,000. And then let's do const, we'll do output. So const output equals network.run, and then we can run basically a piece of text against our neural network. So let's say I fixed the power supply. All right, now it should learn from this training data that that's going to be hardware. There is no I fixed a power supply in here, but by this data, by this training data, it should know that the category is hardware. All right, so let's go ahead and console.log, and let's just say category, and then we're going to put in our output. Okay, because our output should be a category. Now let's save this. Now when I run this, it's going to take a little while. It might even take up to like a minute or so. If it does, I'll just kind of, fast forward it. But let's run node index2.js, and let's see what we get. Okay, so this is what we're going to get for I fixed the power supply. All right, so we got our result, and we got category hardware, which is correct. All right, so let's try something else. Let's see, what about like maybe the code had bugs. I found some bugs in the code. Yeah, so we'll say the code has some bugs. So let's save that and let's run it, and we should get software as a category now. There we go, software. All right, so it does take a while, but that's just that's part of machine learning. It's gonna take a while. Some libraries, obviously, some of the Python stuff is a lot more powerful, but we are dealing with recurrent neural networks here, which do take longer because we're using strings, and the longer the string, the longer it's going to take as well. So yeah, so I think that's going to be it, guys. I just wanted to kind of show you how to get Brain set up, talk a little bit about neural networks and how they work, and how we provide them training data, and how we can run something against the network and get a result. And I think we did that. So thanks for watching, guys, and I will see you next time.